In template metaprogramming 10, generic lambda for spinet 2, in this video, I scroll down, Mr. Ant Gregat, sorry I cannot pronounce your family name, left a message like this. When you wrote element instance on 3 minutes 48 seconds, why couldn't you leave the return type as type name t-value type, but instead you did std declval of it? When you create algorithm, especially for template metaprogramming, you should always use declval. I filmed this video long ago. To save time, I haven't watched this video again. In some case, you can return value type, but using stdval is more generic, fail-safe. It is the safer way. I will explain why in this video. In more advanced application of linear algebra, elements of our matrix is function of t in this case. As you can see, matrix and vector elements of this matrix is a function of t. This is vector. Elements of our vector are function of t. We multiply the matrix with a vector. The result is function of vector. This is another example. In this case, our matrix is a function of t with complex numbers. So we should be able to implement matrix of complex number, matrix with elements of function with complex numbers. Elements of our matrix can be function with complex numbers. This is another example. Elements of our matrix is function. In this case, it used one variable t, but we can have multiple variables, 2 or even 3 variables. But this is not all. In more advanced case, we do not have such pretty functions. We have a series of data. Each element of this matrix can be a series of data. From such data, we have to interpolate and generate these functions to calculate our matrix. But don't worry, if you keep watching my videos, we can create such matrix in C++ rather simply. As long as you do not skip my videos and watch my videos carefully, you can implement such matrix. I guarantee, because I already implemented it. I already implemented matrix that can take functions as its element. This matrix is very short. It starts at line 114, ends before line 200. It used only 90 lines or less. As you can see, it is very short implementation. It used only about 50 or 60 lines of code. This matrix is super powerful. Elements can take discrete data. We are creating this matrix. This is function f0, one element of the matrix, f1, f2. Each function can take 3 independent variables. What is more important and powerful is that this function element of this matrix can take arbitrary data and capture. This is weighted mean, but this function can be any function with discrete data. To implement this matrix, we need a few advanced modern C++ programming techniques. For example, get member types In this case, this is function definition. This is return type specification. This function does not have function body. It only has declaration. Using this getMember types, we use declval. Using this declval, we can implement matrix that can take arbitrary data type as its element. Elements of this matrix can be simple scalar or value, or functions of a single independent variable, two independent variables, or each element can be data set. Using those discrete data sets, we can generate each element using mathematical interpolation. So this simple matrix defined from line 114 ends at line 190. It is super powerful. To implement this matrix, we need to understand fold expression, function without function body. We need to understand the declval. We need to understand the reference wrapper. We need to understand the C++ 20 concepts. We need to understand multiple metrics in C++. We need to understand how to implement multidimensional metrics in C++, theory, and coding. We need to understand how to use make integer sequence. We need to understand pack expansion in Lambda Init-Capature. We have to understand all these concepts. One thing good is that I already filmed about these concepts, but std declval. I think I filmed about this, but I cannot find it in my playlist. So in this episode, I will explain how to implement declval and why it is so important. Please understand that we can differentiate each element of this matrix or integrate. We can take partial derivative of these matrix elements. Also, if you want to know how to implement complex matrix, I will provide you this list in this script. Without further ado, let's get started. Start Visual Studio Code. Open your working folder. Create a new folder 087 declval, add reference. Hit enter. Click this button declval.cpp. Hit enter. Ctrl B. In this episode, we will learn why std declval is super important in template metaprogramming. We will also learn how to implement std add reference, std add rvalu reference, and std declval. In my next episode, we will dissect std to understand how it is implemented and how to optimize our code that is using std. We also need to understand why we should use std reference wrapper for optimization purpose. Include talkplayFun, output HPP, talkplayFun, sstream, stream, oro, endl, talkplayFun, endl. Void test declval, anti-main. Copy the function name, paste it here. Now start command prompt dir cd 087 declval add reference. We will be using clean compiler std C++20 declval.cpp ltvv oc.exe. It should build successfully. Also, GNU compiler should build successfully. I will copy this command string, copy, and paste it here for your reference. Also, we will test with Microsoft compiler 087 declval add reference clehsc std c++ latest declval.cpp fe m.exe. Hit enter. Microsoft compiler also should work. I will copy this string, copy, paste. When Microsoft Visual Studio 2021 is released, the command should be, it can be 20. Okay, now here using vector t std vector std any, we defined vector t m is matrix or f0 or forwarding reference s or forwarding reference t. Don't forget semicolon, return s plus t. I create one lambda closure f2 1. I will simply make like this, copy, paste. This is 2. I will make it s square. This is 3. I will make it st. It doesn't matter. Sorry, I will cut this part and paste it here. Then we can initialize f0, f1, f2, f3. Then we build once again. We will be using Microsoft compiler. Okay, it works successfully. Now, we cannot use this vector m without knowing the type of f0, f1, f2, f3. If we do not know the type of f0, f1, f2, f3, we cannot access the elements of f0, f1, f2, f3 of vector m. We cannot use because the element of vector is stdne. We have to know the type of this lambda closure. For this purpose, here template type name types or get element types. This is a function. Here no except is important in some case. Then we have to specify return type std tuple. Then here types like this. Okay, because tuple can take one or more elements. Why is squiggle? Let's try it. Before we try, we will create a macro. If not def talk play fun get element types, and if define, we define this macro. This is parading macro decl type. We call this function. This is function. So we have to provide argument va args. This is periodic macro argument. Now let's see how to use this. Scroll down using lambda types talk play fun get element types f0, f1, f2, f3 stream types of f0, f3, talk play fun, get type name, we provide lambda types, and then now we build with Microsoft compiler. It built successfully M. Now if we compare lambda 1, this is type. 2 means it takes 2 parameters. This is lambda 1. Its type is f0's type is lambda 1 taking 2 parameters from the function test declval void. From test declval void. Now second type f1 is lambda 2. So the type of f0 and the type of f1 are different type. f2, this is the type of f2. This way we can find out the type of f0, f1, f2, f3. These are all different types. If we try with the Clang compiler, it also builds successfully. CLS C. In this case, it gives message like this. Lambda at declval cpp line 35. Line 35. In the second case, line 40. Third case, 45. Lastly, 50. So, line 50. Now, with GNU compiler, CLSC, in case of GNU compiler, it gives parameter type 2. This is lambda f0. This is lambda f1. All types are different. Now, here, template, type name, types. Using element types T, we call this function like this. Now it should be types. We have to provide instance. Okay, this is correct. Don't forget semicolon. We have to provide an instance because this is function. In this case, tuple, we provided a type. In this case, we provide instance. This is instance. Now scroll down. Here, using element types T, we are calling this type function. Then we provide decl type. f0, we have to provide type. I made type here, decl type. Decl type. This is 1, decl type. 2, decl type. f3. We display once again. Now this time, element types. We build again. The result should be the same. CLSM. So this line should be exactly the same. In this case, we used macro. In this case, we used type function. Sometimes this is more handy, more useful. Sometimes this is more useful. So we defined both. This macro, this type alias, both uses this function. It does not have function body. Also note that this keyword no except is sometimes important. Now I will copy this function. I copied up to this point, paste. Now this is test advanced decl type. Now I copy this, paste it here. I will disable it. Scroll up. Now here, std vector double m 1.0 It is not M. It is B. 2.0, 3.0. Okay, we defined vector. We don't need a double here. Since C++17, we don't need to provide template argument. Now we build once again. CLS, it works perfectly. Now scroll up. We provide here B. We don't need this B anymore. Then std move B. Okay, we don't need this B anymore, so we move. Now we build once again. CLS, Microsoft compiler, failed. At line 34, advanced declval lambda 1, no appropriate default constructor available. Line 34, here, no appropriate default constructor available. When we capture B, default constructor is not available. I will remove this part once again. I removed. CLS, we rebuild. It works. When I capture, we rebuild. I will delete, then rebuild. It does not work. No appropriate default constructor available. Now, here, line 34, if we change it, std declval, now this is a function like this. We modified, we rebuild, CLS rebuild. It now works perfectly. This example shows why this declval is so important. Now we can add here more vectors. Now W 2.0, 3, 4.0, 6.0, 7.0. Now this B is supplied, captured only F0. But now we use lvalue reference because I will pass it here too, here too, here too. Because this is lvalue reference, this W, this W, this W, this W only takes address of W. So we can use, for example, W0 times W2 times, in this case, times W3, in this case, plus W3, in this case, minus W0, 1, 2, 3, 2. All these works. Now we build using Clang compiler, GNU compiler. It should work. Clang compiler, it should work. Please understand that this V is used only once in this lambda, so we can move. After move, this V is invalid in this scope. In case of W, it is shared with multiple lambda, so we have to take it as lvalue reference. But in this approach, there is two big problems. First, we cannot return this vector M with element std any, and F0, F1, F2, F3 are lambda that capture W as reference. Once this function test advanced declval goes off this function block, the lifetime of W is destroyed. So If we want to return vector m out of this function, we have to use shared ptr for w. Another problem is that the element type of m is std any. These lambda f0, f1, f2, f3 are copied to this m. std move, it works. With std move, it still works. This session becomes too long. In my next episode, I will explain how to implement declval and std add reference, std rvalu reference. In near future, we will implement metrics or functions with 1, 2, 3, or more independent variables. We can differentiate each element or take partial derivative, or we can integrate each element. We can multiply two metrics with functions we can copy, etc. We can create complete matrix class that supports complete features that are expected from matrix class.